Hello, welcome back to our certificate course. This is week 3, session 2. Earlier we have already covered how to start a research, how to do good research by selecting a good topic. We have already covered types of research, stages of research process. In this session, we will be covering sampling methods and sample size calculation. We will be first discussing why sampling and what we do in sampling and what is the concept of sampling. Before we go for sampling, we need to understand that from population only we draw a sample. So, we need to understand, explain, classify the concept of population. Population in one way can be finite population, infinite population. For example, students of a college could be example of finite population, stars in the sky could be example of infinite population. In another way, we can classify population into known and unknown population. Then from this population, we try to select a finite portion of the entire population that should be representative, and we call it a sample. We will be introducing one more term, sampling. Try to understand, listen to me carefully, sample and sampling, they are different. Sample is just a noun, a finite portion of the population, where sampling is the way we draw a sample from population. I am introducing one more term which is more important, called sampling frame. This is often bit confusing for the research scholars. I would request you try to understand what you really mean by sampling frame. Sampling frame is the list of all units of the population. Again I repeat, sampling frame is the list of all units of the population. So, please understand, sometimes we may not have a sampling frame at all. Surprised? How we cannot have sampling frame? Think for a while. When the population is infinite, we cannot have the complete list. So, in those cases, if population is either unknown or infinite, we will not have sampling frame. Please be careful. Once we know the population or the sample, then we can go for the selection of sample units. Now, one more important point in the sampling procedure, do we have to follow strictly a rigid technology, a rigid method, and if so, why? I will be giving example of a person called George Gallup. Many of you must have heard of Gallup poll, and some of you might not heard of a eminent professor George Gallup. George Gallup, one of the pioneer researcher whose doctoral research was on the objective methods for measuring readers' interest in the newspaper, and it was published in 1930. He used some old theory, a 200-year-old theory, Bernoulli probability theory. He wanted to prove you need not solve, you need not check, you need not survey the entire population or everybody, because if you are selecting a good sample, if you have selected a randomly perfect representative sample, then your result will be equally trustworthy and accurate. This is for the first time he showed to the world that the research based on a sample could be as trustworthy as if you are taking instead the entire population, and his work was flashed in the headline, and he was invited, full-time professor from University of Iowa, Drake University and Northwestern University. You can see from the Time magazine, he was the newsmaker and his story was flashed world over. Now, let me tell you what he did. I will be giving you a small simple example which would be the gist of the work done by Gallup. He was suggesting, say for example, you are selecting beans from a big container, say for example 7,000 white beans and 3,000 black beans, you shuffle it. And suppose you wanted to take 100 beans, and if you take a well shuffled sample of 100 beans, you can very well expect 70 white and 30 black beans almost approx. He was suggesting if you repeat it for 1,000 times, you are going to get around 900 plus times, and it can go up to 997. So that means the accuracy level could be 99.7%. So this is something interesting finding. One should know how sampling based research could also be equally efficient. Next example could be, I will be suggesting on the famous Million Man March, which was really very interesting event, and it happened during 1995. The civilians wanted to protest against a law, and the president was really shocked, but he was not caring, trusting that if Million Man could come to his office. But the protesters wanted to show the president, yes, there would be the million protesters. And the president employed Howard Jacob, who wanted to count how many protesters were there. And this is called Jacob's method. As you can see from the exhibit, he wanted to check if it is countable 10 by 10 square feet, how many persons are there. The total courtyard, if you multiply by different squares, then one can estimate how much would be the total striking population gathering in front of the office. So this kind of Jacob method later was applied to huge crowds. Say for example, famous car festival of Odisha, Puri, Rath Yatra, suppose crores of people are coming and going. How to estimate how many people had come? You are not doing the head count. So if you take a small portion, say maybe 10 meter by 10 meter, and you count how many persons were there, suppose the entire road which we call Bodadanda, we can have the rough estimate, and this is nothing but application of Jacob method. Now, having given you two examples, now let us try to consider why we will be going for sampling method. All said and done, try to understand, if you are checking the entire population, of course that will be most accurate. But mind you, you cannot check, survey the entire population because of many reasons. It could be huge task, it could be very costly, we may not be having sufficient manpower, and sometimes you may not be knowing the population. So when census method is not population, then we go for the sampling method. So how do you do the sampling method? Now these are few points that all of us must understand. First, we should try to understand, identify the target population. Please remember, I am repeating, it's just not any population, but I am talking of target population. If you are making a survey of the second-hand car users or consumers, you need to refer to those who are purchasing second-hand cars. So that would be my target population in that survey. Next, we will be checking whether I am having a sampling frame or not. We have already discussed, sampling frame may not be available always. In case we are lucky, we are having a sampling frame, then we can resort to a particular type of sampling. I will be suggesting, if sampling frame is not there, what options are there. Then we go for appropriate sample selection, then only we start our field work. So we have defined why sampling, what is sampling. Now let us put it as a step which is called research design. We had already discussed in earlier session different stages of research, and there you might have remembered one important step is called research design stage. For research, we usually have some particular objectives, then we try to answer some research questions as part of the research process. So this research design, we can say a roadmap or a blueprint for conducting our research. This comprises of selections of methods, techniques, procedures and the sampling plan which we are discussing now. So, let us discuss briefly about the sampling types. Broadly, you can classify different samplings into two ways. One is probability sampling methods, other a set of methods which we will be putting as non-probability sampling method. When you are trying to understand differentiate between probability versus non-probability, please remember two words, two synonyms. It is chance factor or our choice factor. Repeat, chance versus choice. They are the synonyms of probability sampling and non-probability sampling. So, when you have got two options, the question comes to our mind, which is better? Is probability sampling better or non-probability sampling better? I will not be answering right now. I sincerely hope you will get automatic answer within the next 4-5 minutes when I am discussing something. But let me show you one example, very interesting example. Say, one of us is making a study on gold consumption of Indian marriages. Say for example, if you can see the pictures and some brides you can see. So, I think we can take them as sample. This is how we have the gold consumption, particularly for celebrations like marriages. So, can you take this as good sample? Again, I am not going to answer. I hope you will be getting the answer very soon. Now, let me first classify different types of probability and non-probability sampling. I would prefer explaining first the group of non-probability sampling. Under non-probability sampling, we first can have convenience sampling. When accessing sampling units is felt to be a bit cumbersome and you may not get equal access, then most adopted sampling method under non-probability is called convenience sampling. It is mostly for convenience of the research, not for the convenience of the researcher. Repeat, this is for convenience of research. Next would be the purposive sampling, and purposively we select a group or some units as per our judgments. Say for example, we want to employ watching the activities of the student. We might not give this role to all employees, we might give to some selected employees who are good at that. Next could be quota sampling, when we need to have some reservations and we should go by some reservation of categories which we will be calling quota sampling. Last but not the least, under non-probability sampling is called snowball sampling, which is really very interesting in researches. Please remember, snowball sampling is one where we do not easily get the sampling units. We do not know where they are. I can, in light of it, suggest, say for example, one crime happens. How do we identify who has done the mistake, who has done the mischief? So, what police does usually, they randomly pick up somebody whom they suspect and maybe like asking that particular suspect, they might get further information who could also be involved in that scenario. So, from one, when you go to other, that is called snowballing or referencing. One gives information about the other sampling unit, that is part of snowball sampling. Now, let us go to the set of probability sampling methods. First and foremost and the most popular sampling method among the researcher is called simple random sampling, or in short we have got SRS. Let me tell you, this simple random sampling can again be of two types. One with replacement and the other without replacement. Suppose you are selecting one and then again replacing back, that is called with replacement. And once one is selected and you do not want to replace it again, that is called without replacement. Next will be systematic sampling. This is usually applicable when you are doing one survey in a large stretch of sampling units like households or in one orchard, you don't resort to simple random sampling where you may be getting any unit. In systematic sampling, what you do, we select the first few units and draw randomly one unit, which we will be calling a random stat or the first unit. Then we go on adding a constant number to go to the next unit systematically. Thus, we call it systematic sampling, or to be particular, systematic random sampling, where the first unit alone is drawn randomly and other units of the sample are automatically, systematically selected. Next, let us discuss about the stratified random sampling, which carries lot of importance in socioeconomic survey, marketing research, where we find if a population is not homogeneous, if a population is heterogeneous or be diverse, if you are selecting randomly, then it may be you are not getting proper representation. In those cases, what you have to do, you have to first classify, divide or stratify the entire population into different strata. Please remember, strata is plural, stratum is singular. So, you get many strata, and from each stratum we have to select randomly a few units so that we give representation to each strata. For example, for a socio-economic study in one locality, we know that the living standard or per capita income varies. There could be super rich family, there could be rich family, there could be middle income group, and there could be lower income group families. So, if we first classify into rich families, middle income group or MIG, lower income group or LIG, then we select units from each of those categories. That is part of stratified random sampling. Next would be cluster sampling. Some of the cases you find that units are highly concentrated in one area. Those are called clusters. Like firecracker units. Many of you must have heard a place called Sivakasi. Sivakasi is famous for firecrackers. If one is about to study the living standard or the hazards faced by the workers of fireworker industry, they need not randomly select any place, any geographical area, but can go to that cluster of units, right. So, the last one is multi-stage area sampling. Area means geographical area. If we are to conduct a survey or research comprising of a huge geographical area, what you can do, stage by stage we can divide the geographical area. Say for example, if we are to have a quick survey on the literacy rate of different states of India, possibly we can first divide the entire country into states, stage 1, and select few states. Then from those states we select few districts as part of stage 2. Then further within those districts we can go to subdivisions or blocks or tahsils as stage 3. So, we are reducing the quantum of work stage by stage, thus it is called multi-stage area sampling. Next, let us try to understand few finer points as part of the issues in sampling. First, what comes to my mind is part of the non-random sampling. If it is not random, there could be personal bias, bias of the interviewer, how he or she selects, where he goes, that could be personal bias, that is a part of limitation of non-random sampling. Again, in random sampling there could also be limitations. Say for example, by accident you got the example of that gold consumption exhibit that I had shown, and that is not true representative. And it could be if you are asking few persons, those who are opposed to one political party, and there could be also the bias. Another interesting concept in sampling is called survivor bias. I will be taking some time explaining with exhibits the concept of survivor bias. This is really very interesting, hope you will enjoy. I will be starting with one of the publication on the violence among the couples staying under live-in relationship. Now sometimes those relationships last, and sometimes we find fallouts, arguments and violence in the relationship. Say for example, there is extreme case of violence and one of the partner is the survivor, and we are investigating about the details. Say particular person, there is a long scar on the face or cheek, and there could be the attentional bias, and we might find the other partner might have done this, but we have not seen the other partner. Please remember, it might be more serious with the other partner. The partner who is not present might have been also dangerously victimized. Say maybe like one ear is lost or nose is lost or bitten by the partner, and we are just seeing one person, and this is called survivor bias because we have got attention on whom we are meeting or the survivor. Another interesting example I will be explaining which happened long back during Second World War. As you recall, it was against Germany and lot of aircrafts were damaged. Now the strategist, particularly from the British Royal Air Force, wanted to protect their fighter planes by plating the planes, and the plates are very heavy, and they wanted to plate the portions of the fighter planes in the area where it is most hit. Repeating, they wanted to survey which portion of the fighter plane are usually hit by the enemy guns. So some experts checked whatever happened, and they studied exactly the bullets where it is found and the distribution of the bullet shot. They found that in the fuel tank, fuselage area, it is the most sensitive area. So the military experts suggested Royal Air Force, better we should have bulletproof plating to that area. Then they invited one statistician called Abraham Wald. He suggested, wait, you have done a mistake. He suggested the bullets, what you are finding is not the sensitive area what you are seeing. You have not seen the portions which is actually most sensitive. So the missing bullet holes were on the missing holes what you are not seeing. Try to understand, if it is hit on the engines, the fighter planes are not returning to your place. You are only checking, inspecting the damaged planes which could luckily return to your place. And what about the planes which could not return? Maybe it was head-on collision or it was hit on the engines, so you need not plate on the other area, you should have protected the engine portion. So this is what one of the glaring example of survivor bias. Now let's very briefly, we will not be discussing much on this particular aspect of calculation of sample size. When you are to select a sample, if it is known population, finite population, then maybe we have the population size which will be denoting as capital N, sample size will be small n. Here we will be very briefly discussing, we will not be going into details. Try to understand, sample calculation will be a function of some of the factors like the degree of variation, degree of diversity, and how much you can tolerate, which you call tolerance level or alpha, and the confidence level and the cost factor. Can we take larger sample? can we take small sample or not. So, it is a function of Z, S is the variation and E, and we have got several formula, but I would rather prefer giving one example. Say for example, we are surveying about the repeat purchase of cars or the old car consumers. Say my city is Berhampur, which is part of Ganjam district in Odisha. Say for example, there are 20,000 such customers who have purchased old cars. And if you are checking the customer satisfaction level, you could have taken the Likert scale of 5 point, 4 point or 10 point. Say for example, we are taking 10-point scale. So, if it is 10, it starts from 1 to 10. So, the range is 9, and if the variation you are tolerating is 1/6, so it comes to 1.5. Now, please see, these are the columns, one is Z, these are called the normal ordinates. You can take 1.96 or most likely 2.58, sometimes we will be taking 1.645 also, we will be discussing later. Now, if Z is given to be 2.58 and the variation is 1.5 and we are going for 1% tolerance, it could be almost 1500 sample size, or to be exact 1497 sample size. If the variation is 5%, it comes down to 24. If it is more, it can be more. So, this is how we will be trying to consider the sample size calculation. We will be taking more examples later. Thank you very much for the participation. We will be taking off more.